Hello everyone. In this lecture, we will talk about advanced query concepts. We will start by action queries, including update, delete, append, and make table. Then query wizard and special queries, including crosstab, parameter, duplicate, and unmatched queries will be discussed. Finally, you will learn basic concepts of SQL language, which is used to create complex queries. As I mentioned in the last lecture, action query is one of the advantages of query over the regular filtering approach. Action queries are another form of query that can perform an action including update, append, and delete the records, or make a new table based on the defined criteria. Let's start by update query. An update query is an action query that changes a set of records according to the criteria that you specify. When you want to define an update query, you don't need to add any field except the target fields that you want to use to update the table records. Please consider that when you use update query, the records of the original table will be updated. In this example, we want to add $2 to the hourly rate of the personnel who are employed after 2017 and $5 if they are employed before 2017. For this purpose, go to the query design and change the query type to update, then add the employee table and add hourly rate field. As the next step, in the update row of the hire date, use if function to see whether the hire date is after 2017. If yes, add $2 to the hourly rate, otherwise add $10. Finally, click Run to update the records. Watch update query demo in the next slide.
For example, I have my book project table open, and the field values that I'd like to update is the book price by 5%, but not for every book, just those books whose part numbers begin with 10 and let's do 14, not the 11s. So let me go ahead and close out of here, and I created the query based upon this table, and it's this one right here, retail price. Double click. It pulls in only those part numbers that begin with 10 and 14, again not the 11s. We got the book title and the original book price. And then I created a custom calculated field to see what it looks like when I multiply the original price by 5%. And so if that looks good, we can go ahead and convert this query into an update query that when I run it, will not only update it here, but again, because this is based upon the book project table, double click to open it up. It'll also, you'll see it there, the price increase by 5%. Let's go ahead and close out. And let me go over the makings of this. Let's right click, go to the design view. And so for the part number, down below in its criteria field, I use the wildcards. So I've got 10 and then the wildcard, meaning that it has to begin with 10, the part number, and then what comes after it doesn't matter, could be anything, it's wild. And then we've got the or, meaning it could be 10 or like 14. So it has to begin with 14, the part number, then the wildcard, doesn't matter what comes after it, just has to begin with the number 14. And then I got my custom calculated field that I just typed in here in this blank field. Well, it's now not blank, but let me right click on it and go to zoom so you can see it. I've got the name of the field and then the colon that separates the name from the expression. On the right hand side of the colon is the book price field in brackets, the asterisk to multiply it by 1. So we got the original price and then 0.5, 5%. Let me go ahead and click cancel. Now again, I don't need the new book price here, just want to see what it looks like. So to get rid of it, let's hover over that top thin gray bar until I can see a black arrow pointing down, click on it to select the entire column and then hit the delete key, it's gone. So when I go back to the datasheet view, there you go, the original price. And let's go back to the design view. And before I go ahead and convert this into an action query and have it multiply by 5%, it's probably a good idea to make a backup, in this case, of my table. So that way when I update it and I'm like, I made a mistake, I can go back to the original. So let's make a copy of it. We can do that by right-clicking on it, going down to Copy, and then just right-click anywhere in the navigation pane and go down to Paste. And then it shows you it's going to make a copy of the book project table. That'll include the structure and also the data. Sounds good. Click Okie dokie, and There we go, a copy of it. So if I mess this up, we've got a backup. Let me go ahead and drag that down. Those scroll bars, they so annoy me. And then let's come up here on the Design tab to the Query Type group, and there you go. Every query that you create from scratch by default is going to be a select query until you come in here and you say, okay, let's convert it into an action query, which is any one of these queries over here. The one that we're focused on is this one right here, the Update Action Query. When I select that, down below on the grid it says, fine, you want to update something? What is it? So it adds the Update To row, and we want to update this, the book price, by 5%. So let's go ahead and type in the book price field, open square brackets, BOO. After I type in the first couple of letters, you see it pulls up all those fields that are available from this table in this query, including the book title. I just want the book price. So with it highlighted, hit the tab key and it pops it in those square brackets. Then we want to add the asterisk so we can multiply it by 1.05. Hit the tab key to make sure that it accepts it. It does, and we're good to go. So if I come up here and I click on the Run button, here's the difference. When you run, that means you're going to perform an action, as opposed to just viewing it. When I click on View, it doesn't perform an action, just shows me the only field there that's going to be affected when we do an update and click the Run button is going to be the book price. So if you're like, wait a second, what were the other fields? You can go back to the design view, look at them here, or you can always go back to the select query and it removes that row. So when you click on Run, it doesn't matter because, again, it's not an action query, it's a select query, so it doesn't matter if you go View or Run. We go back to the way we were here. And before we go ahead and click Run, let's memorize one of these book prices for the book title, like basic medical billing. It's $34.50. So when we increase it by 5%, it'll not only show it here, but again, because this query is based upon the book project table, it'll also update it there from 34.5 to about 36 something. So let's close out of that, come back up here, go to the design view, and then let's go back to our update query. Now, do we have to add that expression in again? No, it remembers it. So if we're good to go, let's come up here and click on the Fun Run button, and it will perform the action specified in our query. Click on Run. Gives us a warning. It says you're about to do this and 17 rows are going to be affected. So it already knows what's going to be happening and, well, how many rows are going to be affected. And if you're okay with that, click Yes. That's it. We're done. You want to see? Alrighty. Let's go ahead and click on the View button. You don't want to click on Run because if you do that, you run it again. I mean, you do get that prompt. You just can go ahead and click Cancel, but let's click on the View button. And it went from 34 to, hey, 36.23. How about the book project table that's based upon DoubleClick? Hey, 36.23, it works. Let's go ahead and close out and go back to the design view here. Click on the button, back in the design view. And if you want to keep this action query, the update by 5%, so maybe in a few months we can go ahead and update it by 5% again and so on. Well, before I go ahead and save it, remember we changed it from a select to an action, an update query. And down below, right here, you've got that icon that represents a select query. So when I come up here and I click Save, it updates it to that icon that you see right here, the update query. And you want to keep that in mind because, to me, that's more of a warning. It tells me it's an action query because it's not like the others, where the icon represents a select query. But when I go ahead and, well, let me close out of here, double click on it, it'll actually want to run it. So with the others, it goes right to the datasheet view, right? Double click. Okay, that's a parameter query. That's not a good example, but double click and goes right to it, right? So this one, when I double click on it to go, let me go to the datasheet view, it's like, uh-oh, you're about to run it. So that's not a good idea unless you want to run it without having to open it and hitting the Run button, and there you go. I don't want to do it, so let me click on No. And so one other thing that you want to probably change, besides the icon, to let you know, if you don't have it memorized, that that's an update query, is you can rename it from QSelect, which is Q for query, and SEL for select. Just right-click on it and go to Rename. And then down here, we'll leave the Q there because it is a query, but just go ahead and type in UPD, and then delete SEL, and then hit Enter. So Q, query, UPD for update. So that way I know it's an update query. Now again, if I go ahead and I double click on it and run it, remember the book project table, the price now is $36.23. If I go ahead and double click on it and run it, you want to do this? Yes. You're about to update 17. Okie dokie. Hey, it doesn't show it here. Well, of course not, because we already have it open. If it was closed and we open it up, it would show the update. But because we already have it open, we can close out and open it back up, and it would show the new book price, or since we're already here, just come up here in the records group, click on refresh, and there's the new price, 38 from 36.
Delete query is the next action query. With the use of this query, you can define some criteria and delete some records based on the defined criteria. In this example, we want to delete all the personnel who are employed after 2017 or before 2010. For this purpose, go to the query design, change the query type to delete, and same as the update query example, add the employee table, then add hire date field. As the next step in the criteria row of the hire date, type after 2017 or before 2010. Finally, click Run to delete the records. Watch delete query demo in the next slide.
We can go ahead and set up criteria that says, okay, for all the records here, just find those records whose part numbers begin with 15, and then after it finds them, we can destroy them or go ahead and process the deletion for those 3 records. Now, why would you want to do that when it's so simplistic here? Well, you can imagine if you had dozens or hundreds, do you really want to go ahead and click on one, hold down the shift key, and well, scroll first, then hold down the shift key and click? I don't. Or maybe you're going to have something more complex. Maybe you want to delete all those records whose part numbers begin with 15, 17, 25. Well, you get the idea. In any case, we're going to use the query to find what we're looking for, and then we'll update it to an action query where it's actually going to delete what we found. And we want to find these 3 whose part number begins with 15. So to do that, come up here, click on the Create tab, go to the Queries group. Let's do it by design. Click on it. Okay, which table do we want to delete this from? Is the new projects table, because remember, we appended or added them over into the book projects, so we're done with these 3 as being new, but something that we can now sell. So let's go ahead and double click to add that, close out, and let's go ahead and hover over the bottom and stretch that open so we don't get any scrolly bars there. And remember, it's going to be for the part numbers, so we can come up here and double click to add that down below into the grid, and then we want to set the criteria for the part number where it has to be, begins with 15, and then add the wildcard, the asterisk after it, meaning that whatever comes after 15, it doesn't matter, but it has to start with 15. Let's go ahead and hit the tab key. It adds the like and the quotes around the 15 asterisks. Let's go ahead and come up here and click on the View button to see if it works. Only those records whose part numbers begin with 15 appear. And if you're like, well, where's the rest? If you need to see it, that's fine. We can go ahead and right click, go back to the design view, and double click on the asterisk, which means it'll include all the fields from the projects table. So when I come back up here and click on the View button, it includes all of them, as well as the part number listed a second time. So here it was first, and then the second time from all the records. It gives us a generic field 0 name. And so we're good to go. Let's go ahead and right-click, go back to the design view, and then to change this to a query, once we found the records that we're looking for, to an action query where it's going to delete what we found, come up here on the Design tab, go to the Query Type group, and there you go, Delete. Let's go ahead and select that. Updates it down below, gives us a row where it says, where do you want to delete? What that means where is where the criteria is, well, in this case, like 15, where it begins with 15, the part number that is. And then we got from the new projects table. So we're good. If we want to go ahead and run this thing, let's come up here, click on the Run button, and it says you're about to delete 3 rows from the specified table. It's the new projects table. Are you sure? It's already open. Because we have it open, well, let's go ahead and click yes. That when we go to it, it's going to show that what was once there is now deleted. Of course, if you had it closed and you open it back up, it wouldn't show you this. But because we already have it open, it wants you to know that, hey, maybe you were expecting something here, but it's no longer there. And you can get rid of that by closing out of it and reopening it as refresh, or you can go ahead and hit the F5 key on the keyboard, and that refreshes it, removes those 3 deleted items.
The third action query is Make Table query. This query is used to copy the records from one table to another table based on the defined criteria. In this example, we want to create a query to copy first name and last name of the employees who are employed after 2017 to a new table called New Employees. For this purpose, go to the query design, add the employee table, then add the first name, last name, and hire date fields. Change the query type to make table, and in the make table dialog box, type new employee. Then in the criteria row of hire date, type after 2017. Finally, click Run to create the table and copy the records. The last type of action query is append query, which is similar to make table query. The only difference between append and make table query is that append query copies the records to an existing table with the same fields, but make table query creates a new table, then copy the records. In order to use append query, the destination table must exist, otherwise you should use a make table query instead of append query. Also, the data type of the source fields must match with the destination fields. For example, you can't copy a text field into a numerical field. Finally, the number of fields of the destination table should be equal or more than the original table. Otherwise, you will face an error message. Watch append query demo in the next slide.
So I've got my book project table, a total of 24 records, and I have in a separate table my new projects that we're working on producing. And of these right here, let's say that we have these three whose part numbers begin with 15 available for sale. So we can move those from what we're working on, or that's going to be new, over into the book project table. To do that, I want to create a query that says, well, just pull in from the new projects table these three whose part numbers begin with 15, and then convert that into a append query that when I run it, will take those and add them over into the book project table. Now I've got the exact same names and data types in both tables, so part number, book title, production cost, come over here, part number, book title. Well, there's the production cost. There's the project manager. Do I have that over here? I'm sure I do. There we go, project manager. Okay, so they're not in the same order, but they're the exact same fields, same names, and data type. So let's go ahead and create a query by coming up here, click on the Create tab, go to the Queries group. We want to do it by design. Click on that, opens it up. And we want the new project table because, double click to add it here, close out. We want to be able to add the fields down below into the grid and set a criteria that says only take those from the new projects table whose part numbers begin with 15 into the query, and then we convert that into an action query that again will update or add those, append them to the book project table. So what I want to do first, so I include all fields from the new projects table to be appended to the book project, is the asterisk. Double click on that, it adds everything there. Now what about my criteria that I only want those records whose part numbers begin with 15? Well, to do that, I have to add that as a separate field. Double click. And so below in the part number, let me go ahead and click in the criteria field there, and let's do 15 asterisks. So there's the wild card. So it has to begin with the number 15, but what comes after it, it doesn't matter, it's wild. Let's go ahead and hit the tab key, and let's take this for a test drive. Come up here, click on the View button, and there we go. It pulled in only those records from the new projects table whose part number begins with 15. And you can see we've got the name of the fields, so there's the part numbers, book title, production cost, all the fields, because that's what the asterisk does. But at the end, we get this funny name, field 0. Well, that's the one that we added in addition to all the other fields. So we have basically the part number listed twice. And because it's listed twice, the second time it's listed, it doesn't get a name. Unless, of course, you want to go back into the design view and change the caption and say, okay, this is part number, but I don't want to do that. And I'll show you in just a minute when I convert this to the append query. We're going to keep that from appending twice. I mean, we've got the part number listed twice, but we needed this to be able to set the criteria, right? So let's go ahead and go back to the design view, right click, design, and oh, you know what, we better save this first. Let's come up here and click on the save button. And since this is going to be an append query, my prefix is going to be Q for query and then APP for append. And then the name of the query, new books available. So go ahead and click okie dokie. and it's right there. Now we haven't converted it yet, so it's still showing the icon as a select query, as you can see up here on the Design tab in the Query Type group, but it's right there, the append to add. Let me go ahead and stretch this open because I don't like scrolly bars. And then to go ahead and do this, let's come up here, click on Append, and then it says, okay, give us the table that you want to take the results here in this query to add them over into. We want to add them into the table, the book project. Go ahead and select that. Click Okie dokie, and then down below it adds the append to row. So it's adding all the fields here because remember the asterisk includes all the fields to the book project. However, it's also going to add the part number here. Now the part number is already part of the asterisk, the all-inclusive, so I don't want to add it twice. Again, I just want to use it to set up the criteria. And so to prevent it from adding it twice, in the append to row, we'll do that one, but not this one. We'll just leave that blank. So that way we get the criteria, but we don't append the part number twice. Okay, and let's go ahead and save this so it'll update the icon from a select query to what we have selected here, the plus and the exclamation point. And you can see the exclamation points in all these, well, not all of them, but most of them, coincides with the exclamation point there because these are action queries that when you want to perform an action and actually run them, well, you just match that up with the exclamation point in any of these, and that's what it does. It performs an action. Those are action queries. So let's go ahead and click Save, and it updates this. And again, to an exclamation point, that's an exclamation point. All action queries, but the plus sign means you want to add. And then, as we learned in the previous training video, the update is a pencil, so it's going to go ahead and scribble something to update it. In any case, let's focus on what we're doing here. Now to go ahead and run it, let's come up, click on the Run button, and it says you're about to add 3 rows. To where? Again, to our book project table that has a total of 24 records. When I say yes, it's done. Let's go to the book project table. Do I have 24 still? Yes. Where's the 3 records that has the part number beginning with 15? Well, because I have the book project table already open, I have to come up here and click refresh, and then, there we go.
There are 2 important points that you should consider after running your action query. By clicking Run, Access shows you a warning message with a number of records that will be affected. If you're not sure about the changes, click No. Also, don't run an action query more than once, especially the update queries. Since every time that you run your query, Access updates the values again. For example, if you have an update query to add $2 to all the prices, every time that you run this query, it adds $2 to the prices. So if you run it, for example, 3 times, instead of $2, $6 will be added to all the prices. The next topic that we want to discuss today is Query Wizard. Query Wizard is an interface that helps you to create queries in a step-by-step manner simply. In order to use Query Wizard, go to the Create tab and click Query Wizard. You can use Query Wizard to create 4 different types of queries. The first one is Simple Query, which is the query that you're already familiar with. By using Simple Query Wizard, you can select tables, fields, and define your criteria. We will talk about crosstab, find duplicate, and find unmatched queries in the next slides. In order to create a simple query, select the first item in the wizard and click OK. In the next window, choose the first table you want to include in the query, then select the fields. For adding the fields that you want to have in your query, in the available fields list, double-click on them or use the Add button to add them to the selected fields list. If you want to create a total query to group the records and see the total value of each field, click Summary and select a function from Summary options. Otherwise, click Detail to show all the records. In the Summary Options dialog box, specify which fields you want to summarize and select the function that you want to use to summarize the field. There are 4 options including Sum, Average, Minimum, and Maximum. Since you can only get total for the numerical fields, the wizard just shows the numerical fields, not all the fields. If you selected the summary option and you have a date field in your table, the wizard asks you to group the records based on a specific part of the date. You can group the records based on year, month, day, and so on. For example, if you group the records based on year, the final result shows the summation or average based on each year. As the last step, you should select a name for your query and choose if you want to open the query results or if you want to modify the query in the design view to add more criteria. Watch Query Wizard demo in the next slide.
To create a simple query using this wizard, click the Query Wizard button that appears in the Queries button group on the Create tab within the ribbon. In the new query dialog box that appears, you can see different ways in which you can create queries. Select the Simple Query Wizard choice and then click the OK button to begin. In the first screen of the wizard, you must select the first table from which you will pull data by using the Tables and Queries drop-down. Once you have selected a table, the fields from that table will display in the Available Fields list. To add a field from the table into the query, select its name in the Available Fields list and click the right pointing arrow button to move it into the Selected Fields list. Repeat this as needed, selecting the fields that you will want to see in the query. When you are finished, click the Next button to continue. If you only selected fields from a single table in the first screen, then when you click the Next button to continue, you will only need to provide the query with a name and then click the Finish button to finish creating the query. If, however, you picked data fields from two or more related tables, then when you click the Next button, you will instead view a second screen which asks if you would like a detail or a summary query. You can select the option button for the type of query that you want to create. If you select Summary, then you will be able to click the Summary Options button to open the Summary Options dialog box. In this dialog box, you can select what type of summary to perform over a selected field. Make your selections, and then click the OK button to return to the Simple Query Wizard. Click Next to continue. In the next screen, if you selected Detail on the previous screen, you will only need to name your query and then click the Finish button to create the query. If you selected Summary, and your summary includes dates, then you may be presented with additional date grouping options. Continue to answer any questions as appropriate for your query, and then click the Next button to continue until you reach the final screen. In the final screen, you must type a name for your query, and then click the Finish button to create the query.
As I said before, there are 4 types of query that have a different usage in comparison with a regular query. These queries are Find Duplicate Records, Find Unmatched Records, Crosstab, and Parameter Query. A Find Duplicate query allows you to search and identify duplicate records within a table. Duplicate record means a record that refers to the same thing or person as another record. In order to create a Find Duplicate query, go to the Create tab and click the Query Wizard. In the New Query dialog box, click Find Duplicate Query, then click OK. From the list of tables, select the table that you want to use and click Next. For example, here we selected Customers table to find the customers who are entered twice or more. This part is very important. Here you should just choose the fields that are the base of your comparison. For example, if you want to find the records with duplicate first name and last names, just choose these 2 fields. In this part, you need to choose the fields that you want to show in the final result. They're not the base of the comparison, and you just select them to show them in your query result. In the last window, accept the suggested query name or enter a name and click Finish to run the query. After finding the duplicate records, you can either edit or delete them in the datasheet view. Watch Find Duplicate Records demo in the next slide.
In the situation I've got here is I've got a number of employees. I've got like 300 employees that are, let's say, contract workers. And there's a number of different kinds of tasks: web development, DB management, graphic design, and so forth. And these employees are sent out on various jobs. So on a particular date, a particular employee works for a particular client, and they do a particular task, whether it's programming or graphic design or several other choices. I keep track of the start time and the end time. In a query that I created in a separate video, I look at the total number of hours and we can come up with billable time and things like that. So what I want to look for are errors in the jobs log. I'm curious, are there any employees that are working two different clients at the exact same date and time? So I want to make sure there's no double entries in here. This could be obviously data entry errors, or it could point to some kind of fraud. So I'm going to go ahead and take care of that. So I'm going to close out of that table. I'm going to head over to my query wizard, and this time I want to do a find duplicates query. Find duplicates query wizard. I'll click OK to start this up. Which table or query do you want to search for duplicate field values? I'm curious about my jobs log. That's where the potential problem might be. So I'm going to go to my jobs log and I'll click Next. Which fields might contain duplicate information? Well, there's a number of fields, but what I'm concerned about is a particular employee. Actually, let's see. I'm going to look for job date and employee ID. And let's see, I think I'll also go ahead and get, nope, that's good. I think I'm going to focus just on these two. Let's keep it as simple as possible, because really this is what I want to draw my attention to. Now, just because the same employee had two different jobs on the same date, that doesn't necessarily imply a problem, but it is something that I want to focus my attention on. It's really going to be a duplication of the date, the employee, and the times. But these are the two that I really want to focus on. Using my job start time and job end time would not necessarily make this a better query, because an employee might have, 5 different job start times in a particular day, but if each job is only 30 minutes, that doesn't necessarily mean there was any overlap. So these are the two fields, the job date and the employee ID, that I really want to focus my attention on. So I'll go ahead and click Next. Do you want the query to show fields in addition to these? Yes, I definitely do. This is where I would definitely want my start times and end times, because this is going to help verify if there's any double billing. So I'll go ahead and bring in all these other fields. I'll bring in client ID, task ID, start time, and end time for the particular job. Next, what do you want to name your query? I'll just go ahead and keep the default name. That's perfectly fine. And I'll click Finish. And I've got 32 records of duplicates. So let's kind of see what some of these results are letting us know. I've got this one employee here, M5216. This employee worked for 2 different clients on the same day, January 23rd. And check out this. For one client, they have a start time logged of 11:40 a.m. to 3:30 p.m., so right there in the middle of the day. Their other client, they started at 8:50 a.m. and finished at 12:30 p.m. So there's clearly some overlap here that warrants some investigation. So there was a period of time where they were, in theory, doing work for 2 different clients at the same time. So this could very well be a data entry, either in start times or end times, or it could have just been a mistyped date when this job was being entered into the database, or it could be an example of a fraud attempt. So that's what the finding duplicates query can be helpful for. And it's finding duplicate information. And now I've got a list to kind of go through and verify. And if there's a problem that needs to be fixing, this is going to help us find that. So that's a find duplicates query in Access.
The next type of advanced queries is unmatched query. This query is used for the tables that are connected with each other, and we want to see if there is any record in the secondary table that doesn't have any related record in the main table, and vice versa. For example, if we have a table to list all of the customers and another table to list the items that each customer purchased, then we can use this query to find the purchased items that are not related to any of the customers. In order to create a Find Unmatched Records query, go to the Create tab and click the Query Wizard. In the new Query dialog box, click Find Unmatched Query Wizard and click OK. In this window, you should select the primary table. I mean the table that has unmatched records. For example, we have two tables called TBL Customers and TBL Orders that are connected. TBL Customers shows list of all customers of a sample shop, and TBL Orders shows list of orders of all the customers. We want to create a query to see list of customers who haven't placed any order. So as the first step, we select TBL Customers. Here you should select the secondary table that will be compared to the primary table. So select TBL Orders. In this step, we should select the primary key and the foreign key fields that were used to create relationship between these two tables. In our example, we select Customer ID from both tables. Customer ID in the Customer table is the primary key, and Customer ID in the Orders table is the foreign key. And similar to the other types of queries, in this window we choose the fields that we want to see in our query result. Finally, type a name for the query and click Finish. As it can be seen, there is only one customer who hasn't placed an order yet. Watch Find Unmatched Records query demo in the next slide.
So I can go to Query Wizard and I can click on the Find Unmatched query. And we have a little description here. It says, this wizard creates a query that finds records in one table that have no related records in another table. So one table may have 20 records, the next table may have 19 records that are exactly the same, but they may be missing that one record, and this is the record we are looking for. Now, why would you actually do that? Sometimes it's done when we're comparing our new table to a backup table that we created a few days ago, or just for analysis purposes, but it is done quite often. All right. So in order to demonstrate how this query works, I created another table, and it is called client list extra records. So I'm going to open it, and this table is actually identical to the client list table right here. So if I open client list, I have 19 records. If I go back to my client list extra records, I have 20 records. All my 19 records are identical. The only difference is this record number 20. And based on the query, we're actually looking for this outcome. Once we run this query, we should only see record number 20. In reality, you may have very complicated databases and you may find hundreds and hundreds of unmatched records. So let's move to the query. I'm going to go and click on Query Wizard and find Unmatched. Click OK. And first, we are starting with the query that has extra records. It could be the query or a table. In my case, it is the table, so I'm going to click on this table, client list extra records. And next, I want to select a table that I'm comparing it to. In this case, it is client list. And finally, I need to find a link between the tables. So what actually links the tables together? And it needs to be a unique identifier. It cannot be a discount because discount is not unique to any single record. We need a unique number or a unique name, okay? The simplest way here is to use the accounts number. So I'm going to select accounts number in both tables and I'm going to link them using this button. All right. Then we click next, and Access is asking what fields do you want to see in the final output. And I'm going to say all fields. Click next. And finally, we need to name this table. I'm going to say 7 find unmatched. and click Finish. And as we expected, everything matched except one record, which is James Baker.
The third type of advanced query is crosstab query, which is similar to pivot table in Excel. Crosstab query can help you to get different reports from your data by showing them in row header or column header. Since crosstab query is a bit difficult to be understood, I'll explain it with use of an example. As you can see here, we have a table with 4 fields. The first one shows the name of the artist, the second one the album name, the third field release date, and the fourth field genre of each album. We want to create a crosstab query, same as the table that you can see in this slide, to show total number of albums of each artist and the number of albums that each artist has released under each genre. As you can see here, we have artist names in the first column. The second column shows total number of albums of each artist, and the other columns show different genres and the number of albums that each artist has published under each one. In order to create a crosstab query, go to the Create tab and click the Query Wizard. In the New Query dialog box, select Crosstab Query Wizard and click OK. Here you should choose the table that you want to use in your crosstab query. Based on our example, Albums table is selected. In this step, you should choose the field that contains the values that you want to use as row headings. Based on our example, select Artist Name. Now we should select the field that we want to have as the column heading. In general, you should choose a field that contains few values to help keep your results easy to read. Select Genre here. This step is the most important part. We should select the function and the field that we want to use for calculation of rows and columns intersections. Based on our example, we use the album name field and the count function to display the number of albums that each artist has released for a particular genre. Also, in order to see sum of all genres for each artist, tick include row sums. In the last page of the wizard, type a name for your query and then specify whether you want to view the results or modify it in the query design. As you can see in this slide, crosstab query could summarize albums table. Now we can easily see the total number of albums of each artist and the number of albums each artist has released under each genre. Watch 2 other examples of crosstab query in the next 2 slides.
Here I got my transaction date with its criteria set up to include only those products that were purchased in the first quarter of 2008. So I want to be able to create a crosstab query that will summarize all those products by month, because here it's separated out by transaction date. So if I come up here and I sort my products, let me click on the drop down arrow and go A to Z, see if this makes sense. When I do my crosstab query on this query, I'll have my row headers as the category and products, and my column header as the date. And then the value between those two is the sale. And I want to be able to set the date up to group it by month. So all the same products purchased in a month will be displayed in that month. So let's take a look right here. We've got the Product Air Mattress in January, and that's the only one in this group that is purchased in January. So we just get one total there. But in February, look at all these. We got lots of them in February. So in the crosstab query, it will take a summary of all those same products in February sold and add them all up and give me one total. So for the month of February, it would be, that one plus that one plus, not that one, skip that one, that one's January, February, and add all those up and give me a total. So let's go ahead and do this. Well, we can close out of here, and we'll save it. And then come up here, click on the Create tab, go to the Queries group, let's do the wizard. Now the wizard's going to ask us a bunch of questions, and based upon our answers, we'll get our crosstab. Okay, first we have to select it. Let's go ahead and select it here, updates it over here. And it says the wizard creates a crosstab query that displays data in a compact spreadsheet-like format. And there's a sample of it. So the darker orange for the columns are your column labels, and for the rows are for the row labels. And so like I said, I want to be able to have my category and products for my row labels. And then for the column, I want to be able to group it by date, and then the intersecting value for that will be the sales. So with it selected here, cross-tab Query Wizard, let's click Okie dokie. And then which table or query contains the fields you want for the cross-tab query results? Well, it's not a table, it's a query, and it's right there. Go ahead and select it, click Next, but how very ordinary. Let's go ahead and go back. Instead, since you're already up here, instead of just selecting it, double-click, and not only does it select it, but it advances over to the next step. Oh, that's so efficient. And then you can see which field values do you want as your row headings. Remember, I wanted both the category double-click and the product. So you can see down below, each product is tied to a category, so that looks like it's going to work out just dandy. Click Next. And then which field values do you want as your column headings? Do you want it the sales or the date? How about a date? Well, not with you. I want to go ahead and double click on it to be able to choose the interval that I want to be able to group it by, and I want it by month. So it updates it down below, gives us a preview. So instead of all these different transaction dates, it's going to group everything that we sold for one product. If we sold any in January and then February and March. Let's go ahead and click Next. And it says, what number do you want calculated for each column and row intersection? Well, there's the sale field, and what do you want to do? As a function, I want to add them all up. Let's sum them. And then it says, do you want to summarize each row? Yes, include row sums. I like that. Click Next. And that's it. What name do you want to give it? It's got the crosstab in it, so I know it's a crosstab query, and I'm good with that. Let's just go ahead and click Finish and take a look. And hey, I've got my category and my product. Now, so for Fanny Pack, it's not listed a gazillion times, and so it's grouped into one for the category, and then we got the total sales, which is a summary of, well, nothing in January, but 76 plus 741 gives us 817. Cool. Now, how about all these extra months? If you don't want to see those because it goes over, you can get rid of that just by, well, right-clicking on the tab, going to the design view. And by the way, up here, the crosstab is an action query, so you don't have to use the crosstab query wizard. You can just go ahead and do it from scratch. Come in here, add your table, select the action crosstab, and then add your fields down below, and then you get your crosstab row where you can choose if you want those fields that you added as a row heading, as a column heading, the intersecting value, and then there's the total of it all, so that's a row heading. And I prefer using the crosstab query, going step by step, or doing it and then coming in here and reverse engineering it and playing with it in design view. But I'm good. Let's come up here in the gray area and right click to go ahead and bring up the properties. And over here in the properties for the entire query, we've got our column headings, which when you right click and you zoom, you can see I just want January, February, and March. I don't want anything after that. So let's go ahead and get rid of that. Click Okie dokie and then close out of here. Click on View, and there, that's more concise.
Here I have a simple customer table, customer ID, first name, last name, and state, the state the customer is from. And of course a real customer table would have a lot more information than this, but this is just for the example. And here I have an order table that lists all of the orders for each of the customers. There's the order ID, the customer ID, that tells us which customer it's for, the invoice date, and the amount of the order. Now, I could have pages and pages of information here in the order table, and just to look at it, it really doesn't tell me anything about the data. So we can use a crosstab query to summarize this information based on one or more fields, so I can see trends in the data that might not be apparent just by looking at the big list here. So let's say I want to summarize this information, showing sales by month, grouped by the customer's state. So I can see all the September sales from New York, the September sales from Texas, the October sales from New York, and so on, in one nice, easy sheet. Well, the first thing we have to do is bring together this information. So I have a list of all of my orders, and I have to include the customer's state. So we'll use a query for that. We'll bring together two relational tables. Now, if you don't know how to use a query to bring together data from two tables, look on my website for my other tutorials on relational tables. But I'm going to close both of these tables down, and I'm going to create a query. Create, query design. I'm going to bring in my order table first, and then my customer table. And that's just so the order table is on the left, makes it easier to see. I want to bring all of the fields from the order table into the query, so I'll double click on the star over here. That brings all of the order table fields over, and then just the fields from the customer table that I want. In this case, I only care about the state. So I'll just bring in the customer state. I don't care who the customer is, because I'm going to summarize this information based on state. Now when I run the query, I can see all of the order information over here and the customer's state on this side. So let's save this query, Control S to save, as orders by state, Q. I like to end all of my queries in the letter Q, so I know they're queries. Now that we have the data together that we want to summarize, we can build a crosstab query. I'm going to close this query, save changes if it asks you to save changes. Let's go to Create, and this time we're going to use the query wizard. Now there is a wizard to build crosstab queries. The wizard is okay. It lacks some features that you can have if you build the query manually. But for today, we'll stick to the wizard. There it is right there, the crosstab query wizard. Click OK. First, you're asked for which table or query contains the data that you want to have in the crosstab query. We're going to use our query here that we just built, orders by state Q. Click Next. Next, which fields do you want to have as the row heading? The row is over here on the side. We're going to put the invoice date as the row heading. So click on invoice date and click on this little button right there. Yes, you can have multiple row headings and multiple column headings, but that's a topic for a future class. Click Next. Which fields do you want as the column headings across the top? Let's go with state for that. Next again. What do you want for the data and what calculation do you want? Well, we want the amount of the order, and the default function is average. Do you want to see the average sale amount in here? Do you want to see the total sale amounts? That's sum. You can see the max or the min, the first or last, the count, how many orders. Let's go with sum for now. We want to sum up the sales by state, by date. And if you want to include row sums, which is a calculation of the total for the entire row, you can leave that box on there. Click Next. What name do you want for your query? Orders by state Q crosstab is the default. I'm going to say orders by state by date Q, and then hit Finish. And Access does its magic and builds for you a crosstab query. Here you can see down the left-hand side all the dates. There's the total for the entire row. And over here you can see they're broken down by state. Florida, Iowa, New York, Texas. That's a simple crosstab query. Now, if you want this grouped even further by, let's say, just month and year, you don't want to see the individual date here. You want all of September sales, all of October sales, and so on. You just have to format the date accordingly in your original query. For example, let's close this. I'm going to delete that query. We're going to build another one. Delete the orders by state by date. All right, are you sure? Yes, I'm sure. Let's go back and edit our orders by state queue. And I'm going to create a new field out here, a calculated field. And I'm going to call this year month, colon. This is going to be format the invoice date field, comma, double quotes, YYYY-MM, close quotes, close parentheses. This is called a calculated query field, and I talk about this in my other classes. And I'm essentially saying, create for me a new field, colon, which is equal to the invoice date formatted in a custom format using the format function, YYYY-MM. That says 2013-11, for example. Now when I run this query, you can see over here my custom field called year month. Now when the crosstab query sees that, it will group together the like year month values. So now let's close this. Save changes, yes. Let's build that crosstab query again. Create, query wizard, crosstab, queries, orders by state queue. Next. What do you want for the row headings? This time I want my year month field, not the invoice date. Next. Column header, state, next. The data, I want the amount, sum, next. I'll just keep that name for now, and then hit finish. And there we go. You can see it used my year month field that I created. Florida, Iowa, New York, Texas, the total, and you can see now how they're all grouped together based on this field. And that is how you create a simple crosstab query.
Although using Wizard for creating a crosstab query is an easy and straightforward way, you can also use Query Design to create or modify your crosstab query when you need more advanced options. In this example, we want to use the Query Design to create a crosstab query for two tables called Order and Order Details. In the Orders table, we stored orders information including their shipping detail, and in the Order Details table, we have the details of each order including the quantity and unit price. As you can see in this picture, the purpose of this crosstab query is showing the total sales of each city during each month. As the first step, create a query using the Query Design, then go to the Design tab and click Crosstab. Then you should use the editor to create your crosstab query. Since we want to create a crosstab query to show total sales of each city during each month, therefore select Ship City field as the row heading. Then create a new field called Month and add it in the column heading. Since we have stored a complete date in the Order Date field, we need to use a function to extract the month of each date. Therefore, use Format function to display only the month portion of the order date. Finally, create another field called Sales and use Sum function to calculate total sales by multiplying unit price by quantity field. Finally, run your query to see the results. As you can see here, we have different cities as the row headings and different months as the column headings, and total sales in the intersection of each city and each month. Parameter query is the last type of advanced queries that we want to discuss. By defining a parameter query, instead of having a constant criteria, users can enter their own criteria every time that they run the query. The query shows a text box and users can enter their own criterion. In order to define a parameter query, we should create a select query first, then add the parameter in the criteria line of the fields that we want to get input from users. Please consider that you should put the parameter text between a square bracket, otherwise it will be considered as a normal text. By running the query, a text box with a text that you typed inside the square bracket will be shown and asks to enter a new criterion. In order to define more complex parameter queries, we can use comparison operators such as greater than, less than, or equal. We can also use parameter query for partial matches. For example, we can define a parameter to enable users to type a part of a phone number. Then the query shows all the phone numbers that start with the entered value. For this purpose, you should use like and wildcards. Also, you should type ampersand to connect the wildcards with a parameter value. Watch parameter query demo in the next slide.
For example, if I have quite a few customers to filter for in my database, if I didn't use the parameter query, then every time I'd have to come into the design view, enter it here in the criteria field for the customer name, run it, then enter the next one, type over it, then run it, and so on. But with the parameter query, I can create a prompt that says enter in the customer name, and it will display the results, of course, once they type in the name. Not only that, but I can give you the shortcut keys, so instead of flashing in between view and run again, to rerun the query, just use the shortcut keys and it'll automatically rerun the parameter query. Well, let me show you. So for the customer name, let's go ahead and put in a parameter query that prompts them to type in the criteria. So let's go ahead and do open square brackets. That's the beginning of the parameter. and then just go ahead and type in the statement. So enter a customer name, and then close square bracket. That's it. Hit the tab key to make sure that Access checks your work after you exit from that field. And if there's any problems, it'll let us know. But since there wasn't any, let's go ahead and take it for a test drive. So when I come up here and click on the Run button, it opens up the parameter that says, okay, enter a customer name. Oh, all right. Well, let's see. Disney CO dot. Hit the enter key and hey, there we go. Isn't that fun? Now you're probably thinking at this point, what's the difference? If I just go ahead and go back to the design view, I can just simply type in the name down the criteria field right there. But here's where it gets fun. So instead of doing that, because I have it set up as a parameter query, if I want to rerun the query, but this time with a different name, I don't have to go back to the design view. I just need to rerun it by, here's the shortcut keys, Shift F9. Oh, it brings it back. Okay, go ahead and type in a customer name. We'll do fall cleaning, hit enter. Oh, that's fun. Better yet, let's go ahead and hit the F5 key. Oh, that works as well. That's nice. Okay, let's go ahead and put in Disney CO period, hit enter, and it brings it up. Now, the problem that you could be running into is that if you don't know the exact spelling of the name, the customer name, because if you don't enter it in exactly as it's spelled, you won't get the results. So if I hit F5 and I'm like Disney CO, hit enter, I get 0. Got to have a little dot at the end. So let's go ahead and go back to the design view and let's tweak this. Make it a little bit easier on the front end user when they run this parameter query. So let's go ahead and click in the criteria field, and to change it, I don't have much room, so let's go ahead and right click and zoom in on that field so it opens up so I can see more of it. And let's do this. Let's go ahead and click at the beginning and type in like. And then the statement, instead of entering in the customer name, how about if we just say enter in the first couple letters of the customer name? Enter, let's go ahead and delete that. So if they know the first couple letters, we'll do the rest. Enter in first couple letters of name. And then we want to click at the end of it, or outside of the close square brackets, and type in ampersand and the asterisk. The ampersand ties the wildcard to the parameter here. So we want to make sure that whatever they type in here, we have a wildcard after it. That means, hey, anything can come after the first couple letters, whatever they type, because it's wild. It could be anything. And then go ahead and click Okie dokie. Hit the tab key to make sure that once we exit, it checks our work. So far it checks out. Let's go ahead and run it. Come up here, click on the View button, or you can do Run, doesn't matter. So it says enter in the first couple letters. Okay, it's D-I-Z-N. Hit enter. There we go. Oh, that's great. How about if we do something a bit more? Let's go back to the design view and change this. Right-click on it to zoom so we can see it. How about if we say just enter in a few letters? As long as it's within the customer name, it'll find it, because maybe they don't remember the first couple letters of every single name. So go ahead and shake this up. Let's click at the beginning, right after the like, but before the first square bracket there. And let's go ahead and do asterisk and then ampersand. So we got a wildcard that's tied to, using the ampersand, to the parameter. So this is saying, with it being wild, doesn't matter what comes before the letters they type in, and then the wildcard at the end, doesn't matter what comes after it, just something, in between. So we could say, well, we better change this here. So let's go ahead and change this, and we'll say enter a few letters of customer name. Okie dokie, hit the tab key, see if it likes it. Let's go ahead and run it. First, enter a few letters of customer name. Let's see, N-E-Y. What's that going to bring up? Hit enter. Oh, there we go. N-E-Y is in Disney Company. Yay! Wait, I'm not done yet. Let's go back to the design view, because what I want to do now is I want to go ahead and add the sales date. Double click on that. How does that work with dates? Well, you could enter a parameter here that says enter a date where it has to meet both conditions here before it pulls up the records. So, it's got to type in the company name or a few letters, and then also a date. But let's do something like a between date, like the start date and the end date. So when we enter in a customer name, the sales date could be between like August 1st and October the 31st for that customer, and see if we have any books that we sold to that customer during that time period. So to go ahead and enter in our parameter query, well, let me go ahead and right click on that to open up the cell so we can see more here. And let's do between open square brackets, enter a start date, colon, and then close square brackets. You don't have to put in the colon. That's not part of the coding because it's within the square brackets, but that's what I'm doing here. And then we'll type in and because it's got to meet this other condition. In other words, they have to enter in a start date and an end date. So let's go ahead and do close square brackets, enter an end date, colon, and then close square brackets. Let's go ahead and click Okie dokie, hit the tab key to make sure it accepts it, come up here, click on the run button, which by the way, when you're in the design view, the F5 key won't work. Let me click cancel. You hit F5, won't work. Shift F9 doesn't work. You have to be in the datasheet view to rerun the query in order for it to work. So when we start off in the design view, we got to give it a nudge and then we can go ahead and use it after the shortcut keys. So click run. Let's see, enter a few letters. I think GH is for Ghost Hunters. Hit enter. And then it goes, okay, enter a start date. Let's see, August 1st, 8/1/08, hit enter. And then the end date, 10/31/08, hit enter. And hey, we found something. We did have the customer Ghost Hunters buy some books between these dates, August 1st and October the 31st. As opposed to, let me go ahead and right click and go to the design view. Let me just go ahead and get rid of the dates and then go ahead and click on the run button and type in GH, hit enter. We had 4 records, now we have 9. So it did capture the books that they bought between those 2 dates, August 1st and October 31st. And what wasn't between those dates were these records right here.
The last topic that we want to discuss related to query is SQL language. SQL stands for Structured Query Language, and it's a language that we use for creating queries in all the database systems, not only Microsoft Access. In fact, when we create a query in the design view, Access types SQL code behind the scene. Similar to all the other languages, we have some keywords in SQL language. Let's have a quick look. Select is the first keyword, and we use it to add the fields that we want to have in our query. The second keyword is from, that is used to add the tables. The third keyword is where, that is used to define the criteria. With the use of order by, we can sort our records based on specific fields. And finally, inner join is used to connect 2 tables and create relationship between them. Here you can see the structure of an SQL statement. You should start writing a SQL statement by typing select followed by the name of the fields that you want to have in your query. Then type from and type the name of the tables that you want to use their fields. If you want to connect your table to another tables, you need to type inner join followed by the name of the secondary table. Then you should type on and type the primary key field of the primary table. Then type equal and type the foreign key field of the secondary table. However, if you don't want to connect your tables, inner join part can be ignored. After selecting the fields, tables, and connecting the tables with each other, type where and define your criteria. Finally, if you want to sort your data based on a specific field, type order by followed by the name of the fields that you want to sort them. In order to write an SQL statement in Access, you should create a select query, then change the view from the design view to SQL view. Here you can see 2 simple examples of SQL statement. In the first example, we want to show all the fields and records from the student table, but in the second example, we want to see only ID, name, family, and age fields from the student table. Also, we want to only see the student records whose age field value is greater than 18. And finally, we want to sort the results based on the family name from Z to A. This example is more complex than the previous two examples, as we want to use the fields of two different tables called employee and salary. In the employee table, we have the information of the employees, including their names and contact details. And in the salary table, we have the payment information of the employees. We want to create a query to show first name of employees who are male from employee table and pay date and gross pay from salary table. To do this, we used inner join to connect the tables, and in the where section, we typed gender equal to male. Watch the demos in the next two slides.
This is the fake information that I've created, and now we're going to introduce you guys to the select query. So let's go to create again, and let's go to query design to create a query, and close this window that says show table. Go to SQL view, and then what I want to do is simply select star, which means select all rows from students. And if you run this query, what you'll see is basically it just repeats the table again. Okay, because every single row and every single field is selected. So that's what this query does. So let's go back to SQL view again. Go back to SQL view again. And this time we just want to select some different columns. So you can see that there's student ID, last name, first name. So let's say I just want to select last name and first name. So I can just go select last name, comma, first name. And if you do that, run it. So design, run, it just selects these two columns. So let's use the where clause. So where basically, so let's go back to the SQL, and let's say I only want to select students that are female. So I can say where the gender is equal to F, right? Capital F with single quotation marks. And if you run that, it only selects all the females in our database. So that's what the where clause is doing. It only selects certain rows. So this part here decides what columns you want to select, and this part here decides which rows you want to select. So I'm only selecting the rows where the gender is equal to female. So only these rows are selected. Right, Sarah, Phoebe, April, and Phoebe, two Phoebes. Alright, so if you go back to query, run it again, and you'll see that only these people are selected. Now, instead of using equals, so go back to the query design again. And instead of using equals F, we can also have something like birth date smaller than or equal to, and let's just put in a date. Let's put in 1st of February 2000. So 1st of February of 2000. Now the dates in Access have to be placed inside hashtags to signify that it's a date. So if you run this, right, actually you can't see the answer if we do that. So let's go back to the query and let's put in birth date. here, so you can see their birth date. So if you run it, then you can see that it's only selected people who were born before February 1st, February 1st, 2000, right? All these people were born before February 1st, 2000. So if I did it the other way, if I went birthday is bigger than or equal to that, then if you run this, it'll only show people who were born after this day. So all of these people were born after that day. So let's say that I want all the students that are younger than the year 2000. So that's what I have here, born after the 1st of February. Let's just put 1st of January. So let's run that. And these are all the people who were born after the 1st of January in 2000. And let's say I only want to list students who's a female. Okay, so then I'm going to go where birthday is bigger than or equal to 1st of January. And then I'm going to type in and gender equals, wait, is gender capital? Yep. Gender equals female. Is that what I said? So if you run this, okay, if you run this, what happens is it'll list people who were born after 1st of January 2000 and the females. So I'm just gonna go back to the select query and include the gender column so you can see that it's right. Oops. View SQL. So yep, we're selecting the gender, their last name, first name, birthday. So if you run it, these people were born after 1st of January 2000 and their gender is female. Okay, now the second keyword I want to introduce you guys to is, instead of and, let's change it to or. And the difference now is that now it's going to list all the people who were born after 1st of January, as well as the people who are females. Not necessarily both. So if you run this query now, you will have people who were born after the 1st of January, and you also have people who are females. So basically you got two things. If they satisfy either of these conditions, so if they are born after this year, this day, or if they're females, they will all be part of the query. Whereas if you put and, what's going to happen is they will need to satisfy both of these conditions for the rows to be included. So now we're only going to get females who were born after the year 2000. So that's the difference between and or. So I encourage you to try that. So now we got females as well as people who were born after the year 2000. So other than and or, I also want to introduce you guys to like. So let's say I want to list people whose names start with B. Okay, so I can go where name, sorry, not name, first name, like, so it sort of means similar to, starting with B, and asterisk. Asterisk just means that it can have anything after the character B. So if you run this, it only lists Brian, because Brian starts with B, obviously. So that's when you would use the like keyword. So let's try starting with J. So go back to SQL, like J star, and let's run it. And I get John, Joyce, Jim, Joey, a lot of students.
Now let's see how we can create action queries including delete, update, append, and create table using SQL language. Writing a delete query is the simplest form of action query in SQL language. You just need to type delete from, followed by the table name, and finally type where, and type a criterion that you want to use to remove the records. For example, this sample statement shows how we can delete the records whose gender field is equal to male. The next action query is update query. In order to write an update query to modify the existing records in a table, type update followed by the table name that you want to update its fields. Then type set and add the name of the fields that you want to update their values. Finally, in the where part, define the update condition. For example, this sample statement shows how we can replace gender field value of the records whose value is male with M. The third action query is append query that is used to copy data from one table to another one. In order to add this query, type insert into, then type the name of the destination table and the fields that should be filled with the records of the original table. Then type select and type the fields that you want to copy. And in the from part, type the original table name. Finally, in the where part, type the condition. For example, this sample statement shows how we can create a query to add first name and last name of the employees who are employed after 2017 into an existing table called new employees table. The last type of action query is create table that creates a new table and copies the records from an existing table into the new table. Same as the other queries, type select, then the name of the fields that you want to copy, then type into and add the new table name. In the from part, type the original table name that you want to copy its records. Finally, in the where part, type the condition. For example, this sample statement shows how we can make a query to copy first name and last name fields of the records whose gender field is equal to male from the employee table into a new table called my table. In addition to defining different queries using SQL language, you can use this language to create a table from the scratch. Just type create table and the name of the table that you want to create. Then open bracket and type the name of different fields followed by their data types. This table shows different data types that you can use while using create table command. If you want to define a field as text, type varchar. If you want to define it as number, type int. And when you want to add a currency field, type currency. As you can see in this slide, we use create table command to make a new table called person with first name, last name, age, salary, and address fields. Please consider that when we use varchar data type, we should define the maximum number of characters that users can type in the field. For example, here we limited the number of characters of the first name and the last name fields to 50 characters. But for address, the character limit is 255 characters. Hope you could learn query concepts completely. In the next lecture, we will talk about how you can create forms for data entry into your tables. Don't hesitate to ask your questions on the course forum or from your tutors. See you guys, bye!